Hey everyone, I wanted to kind of make one last video prior to our quiz, kind of going over quadratics. Like I said, I know this is kind of a difficult thing because it has a lot of things to it. I don't necessarily think that this is difficult in the sense that the math is difficult, but I think it's just a lot to remember and putting it into place about when do I do what when. And so I'm hoping this video will help a little bit with that. But so far, what we've been doing so far is we've been working with quadratics, and that is any function in the form ax squared, so ax squared, oops, that's x cubed squared, plus bx plus c. And again, a, b, and c are integers, so a, b, and c are integers, or just numbers like 2, 3, 7. For the most part, for what we're going to be doing, they're going to be integers. They could be decimals, but what we're going to be working on is they're going to be integers. And then a cannot be 0, cannot be 0. Okay. And that was really our main kind of idea with quadratics. Quadratics is, and this is in standard form, and maybe if you make it a little bit better, y is equal to ax squared plus bx plus c. This is what all of our quadratics forms are going to be in. Okay. And so with quadratics, we should probably ask ourselves, well, what is a quadratic? What does a picture of a quadratic look like? And well, a picture of a quadratic looks like is, let me just draw it quick, just an example. One would be like this. It's not, again, not the best. Sorry, I'm just going to do this on my computer. Or it could look like this. It's kind of this U shape, or this upside down U shape as well. And how we kind of can determine about what each one is, well, I don't know what the graph looks like, but I know that because this is going upward, or what we say concave up, because this is going upward, this a value is positive. So let me just say a is greater than 0 here. Let me just write that down. A is greater than 0. Okay. Versus this parabola here, and parabolas is just the name of the graph of a quadratic. So this is a parabola, that's a parabola, just because it's just the picture of it, where lines are just lines and parabolas are quadratics, really, come from quadratics. But anyways, so that each of these parabolas we have here, this one is a is greater than 0, and this is when a is less than 0. So when a is negative. So it's concave down or going downward when it's less than 0. When a, or that number on x squared, is negative, it's going to be concave down. And so an example of a concave down equation would be, so let me just say, actually let me do this. Concave up example would be something like this. And actually I'm going to be going over these two in a later context. But a concave up example would be y is equal to 2m squared plus 2m minus 12. And the reason why this is concave up is that our a value, or what's on x squared, and in this case is what's going to be an m squared, is 2. And because that is a positive number, this is going to be a concave up. Because 2 is greater than 0, because that's the number on m squared, it's going to be concave up. Whereas concave down example would be, for instance, it would be y is equal to, say, negative x squared plus 2x plus 1. And in this case, our a is just, because we don't have a number on here, it does just have a negative, this a value is a -1. And because that is a negative number, it's going to be concave down. So this would be concave down. Or in other words, what we also can say is it has a maximum value. Whereas concave up has a minimum value. Because if we see here in our picture, concave up, we can see the lowest point's here. And concave down, we can see our highest point's here. Okay. So again, a positive a squared value will give me a concave up picture, or it has a minimum value. And an a value of a negative value would be concave down, or it has a maximum value. Okay. Okay, so now what we're going to talk about is I have three different things that we went over in this mini lesson. Is we had solving quadratics through factoring. Oops, through factoring. We also dealt with solving quadratics through the quadratic formula. And last but not least, we had graphing quadratics. So I'm going to go over each one with its own example. Okay. So solving quadratics through factoring. So, whoops. Okay, so we're going to talk about solving quadratics through factoring. And solving quadratics is just a fancier name for saying, okay, solving quadratics is a fancy name for just saying we want to find the x-intercepts of our graphs. So if we look up here, where does this cross the x-intercepts? That's really what we're trying to do. It's just a fancy way of saying that. So in other words, to find the x-intercepts, well, what we always noticed when we were finding our y-intercepts of all of ours, when we had our y-intercept, that was when our x value was 0. What was the y? So here, let me just kind of draw on this graph that I already have here. This point right here is 0, 2, right here. Versus now we no longer want our y-intercepts, we want our x-intercepts. And very similarly to how in our y-intercept our x value is 0, here for our x-intercepts, or where it crosses the x-axis, this is when our y value is 0. So to find the x-intercepts, we need to substitute 0 in for y. That is what we need to do. So if I give you the following question that we want to solve by factoring, if I give you, okay, so I have insert 7, and again, having r squared is just very similar to x squared, and the reason why I'm choosing this question is because it's one that you had on the homework for that day. So if you want an explanation of this problem, you can have it. This is number 10. Okay, so we had 7r squared minus 14r is equal to negative 7. Well, I want this to one of the two sides to be equal to 0. A lot of times, we would have questions where, and I'll put it in here, where we would have to put, it would be insert equation, it would be y is equal to, let's just say, just give random numbers at this point, 3x squared plus 7x minus 9. Well, what we would need to do first, which we don't have to do in this one because all of, and I'll tell you why for a second, we don't have to do it for this one. But what we would typically do first is that we would just put 0 in for y. Well, this one, the reason why we don't have to do it is because we do not see a y in our equation. But if you were to get an equation like this, where we have y equals 3x squared plus 7x minus 9, we would just put 0 in for y. So 0 is equal to now 3x squared plus 7x minus 9. That would be our first step. But in this case, I don't have a y to put 0 in. So really what our goal is to pick one of our two sides and get it to set it equal to 0. Well, here, the easier side to do this is the right side. And the reason for that is that all we have on the right side is negative 7. So in this case, I just have to bring over that negative 7 to the left side in order to get this equal to 0. And to do that, what I need to do is add 7 to both sides. So now it would be 7r squared minus 14r, and when I add 7 to both sides, negative 7 plus 7 changes that to 0. Okay. And at this point, now I have enough information to start solving this through factoring. And so what we, at this point, I would say this is actually probably step 1 here. Step 1, find the, well, actually, step one would be to, step one, we need to substitute 0 in for y. Step two is factor this equation. So this will always be your steps. Substitute 0 in for y if you can. If not, just get one of the two sides equal to 0. One of the two sides equal to 0. And once you have that, you move on to step two, which is factor this equation. Well, with this equation, the unfortunate piece, because I do think the easier way of factoring is when a value is 1, but in this case, a is not 1, because a is equal to 7, because again, that's the number on r squared or x squared. If you look at here, it's the number that's on a is the number on x squared or whatever is squared. Well, the number on the r squared is 7, so a is not 1. So what we have to do is we have to first find a times c. This is how we factored when a was not 1. We have to find a times c. Well, a again is 7. C is also 7. So then a times c, do it this way, AC is equal to 49. And it was at this point when we factored these types of equations, we now asked ourselves, well, what times what equals 49, but it also has to add up to be negative 14, the b value. Negative 14 is our b value. And actually, I'm going to put a space here so you can see that negative sign. So negative 14 is our b value. And so what we need to do is, well, just start picking numbers, start picking factors of 49. Well, a little bit lucky for us is that there's only 4 factors of 49. 1 and 49, and then 7 and 7. Well, what's awesome here is I need a negative addition. So I can say, okay, I know these two numbers. That's negative 7 times negative 7. That gives me 49. And yes, negative 7 plus negative 7 also gives us negative 14. And so what we did here, and this was kind of, I think, where it got a little bit more complicated when we were solving or factoring equations when a was not 1, was we took our b value and we split it up into negative 7r and negative 7r. So we had 7r squared minus 7r plus 7 is now equal to 0. And again, the reason why we did this is because now we can factor this by grouping. And so this is kind of a really good kind of review for factoring by grouping, factoring when a is not equal to 1. You might have to do it when a is equal to 1. And I will tell you on your quiz, there is going to be one question where you're asked to solve by factoring with a not equal to 1. So this would be a really, 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 really good example for you to study and look after prior to taking that quiz. And there's going to be another example that's going to be solving using the quadratic formula, which is, I think, is a lot easier than doing it this way. But because I asked you to solve it when a was not equal to 1, I need you to do it this way with factoring. But a good way to kind of check your work is to do it with the quadratic formula and seeing if you get the exact same answer. If you do, that's awesome. You know you did it right. If you didn't, then you can either check which one you did, you think you did it wrong, and then you can either ask me questions through email, or you could start thinking about, okay, let's go back to this. What did I do wrong here? But at this point, like I said, now that we've split up our b value of negative 14r to be negative 7r and negative 7r, now we can factor this by grouping. And again, the first thing we did when we factored by grouping was we drew a line down the center. We drew a line down the center, and actually, yeah, drew a line down the center. So here we go. It was at this point then when we have to factor, take out the greatest common factor of the left side and the right side of that line. Okay, take the greatest common factor of the left and right side of that line. So if I look at this and I have 7r squared and negative 7r, well, the greatest common factor, well, what's in both of them with the numbers? Well, 7 and 7, great, that's 7. So I know 7 is going to be one of the greatest common factors between 7r squared and 7r. And then between r squared and r, what's the greatest common factor? Well, that's just r. So then what I have left on the left side after I take out 7r, that is going to be r minus 1. Okay? And very similarly here, whoops. On the right side of this line, between -7r and 7, well, I need to get r minus 1 to be in that parentheses. So what I need to take out is between -7 and 7 is -7, because this will allow me to take out an r. When I take -7 out of this -7r here, let me just kind of draw a little bit. When I take a -7 out of this -7r here, well, all I get left then is, well, -7r divided by -7, that's just r. And then when I take out -7 plus from +7, that is -1. Whoops. -1. And that is equal to 0. And at this point, what we can say, well, I have a an r minus 1 in both. So what I can do is factor out the r minus 1 and say, okay, insert equation, factor out r minus 1. What do I have left of the first term when I take an r minus 1 out? Well, that leaves me with 7r. And if I take an r minus 1 out of the second term, that just leaves me with -7, and that is equal to 0. Okay. And at this point, what we would do is then, okay, now I can apply the zero product property. So step 3, apply the zero product property. And the zero product property states, that if any two things multiply together and gives you 0, so here I have two quantities, r minus 1 and 7r minus 7, those two quantities are being multiplied together and that multiplication is equal to 0, then one or both of the two quantities, two things, are also 0. Because again, if you think about it with numbers, if I have 7 times 0, that's 0. 0 times 6, that's 0. 0 times 0, that's also 0. So if I have two things being multiplied together and it equals 0, one of those two things has to be equal to 0. There's no other way to multiply two quantities together and gives you 0. One of those two quantities have to be equal to 0. So if we look at this, then either r minus 1 is equal to 0, or, as I should say, and or, because they both could be equal to 0, 7r minus 7 is equal to 0. And then I would solve both of those two equations and say, okay, well, if I have r minus 1 equal to 0, if I add 1 to both sides of the equation, I get r is equal to 1. And, or here, my first step would be to add 7 to both sides. 7r is equal to 7. And then again, divide by 7 on both sides. At this point, if I divide by 7 from this equation here, 7r minus 7, I would get r is equal to 1 and or r is equal to 1. So weirdly enough, both of these two got r is equal to 1. That will not always happen. You might get two answers. You might only get just this one that I have here, but r is equal to 1. That is our only solution. So I solved this question through factoring to make it so that where the x-intercept is here, the x-intercept of this function is 1. And actually, if I look at this, if I graph this here, desmos.com. Sorry that stopped sharing, but if I graph that last equation, so if I graph it here, so if I copy and paste it, what we realize, maybe for this one I need to change it to x, It doesn't like it when it's not x plus 7 is equal to y. What I realize again is my x-intercept is 1, and that is my only x-intercept that I have. So when you factor it and graph it, what I notice is, hey, I got the right answer because my x-intercept is 1, and that was what I found out from my solving it. And like I said, I understand factoring was not our favorite unit. I get that. Factoring can be hard just because there's so many different methods here. But I'm going to tell you this right now. The one factoring you have to do on your quiz is factoring when a is not equal to 1. So in this case, that is exactly what I did here. I did an example of that. So what I would do is I would look over this, and if not, I would even watch some YouTube videos, how to factor when a is not 1. Or if you need more notes, look at your notes from when we did factoring, things like that. So this is some really good problem to look at prior to you taking your quiz so that you feel comfortable enough to take and answer that question. Okay. But besides that, that is the only question I am going to have you solve with by factoring, just because it tells me that you know how to do it so that you can apply it in future situations. Now, like I said, solving quadratics through the quadratic formula, in my opinion, is a ton easier because there is a set formula for us to do. So if I have this, the quadratic formula, so again, we're still solving, we're still trying to figure out where the x-intercepts are of this graph, but we're still solving it. But now instead of factoring it, we have an equation that will tell me what the 2 or 1 or 0 roots or zeros of our function is, or where it crosses the x-intercept. It might not cross it at all. It might cross it 1 time, but it also might cross it 2 times. So what we're going to do for this one is, first off, what is the quadratic formula? What is the quadratic formula? Well, the quadratic formula is this, and let me just actually add the equation. Luckily enough for me, oops, I messed up there. Lucky enough for me, they already have it set up for me. So if I do here, scroll down, quadratic formula. This is the quadratic formula. And so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And where this b, a, and c come from is our equation, and it's the same a, b, and c from this equation, from this standard form. So what I would advise everyone to do before they jump into any question on the quiz is always say, well, what is my A value, what is my B value, and what is my C value? Because that might be helpful to do various different things. So here, if I asked us to solve this by doing this quadratic, by solving this equation by using the quadratic formula. So if I have 2m squared plus 2m minus 12 is equal to 0. Great, we already have it solved for equal to 0, so I don't have to do step 1. I don't have to set my equation equal to 0 or set y equal to 0. It already is set equal to 0 for me. So my first step for you, step 1, actually I'm going to say this. If you have to, set equation equal to 0. Here it's already set equal to 0. Sometimes you might have to manipulate the formula where you might have to add 7 to both sides, or add whatever, or subtract whatever. Or you might just have to put 0 in for y. But this time they already had us set it equal to 0, so I don't have to do step 1. It's already done for us. Step 2 then is to label and determine what your A, B, and C values are. Well, in this equation, again, my A value comes from what's on x squared, or in this case, what's on m squared. So A is 2, B is what's on x, or what now in this case, what's on m. So again, B is also 2, and C is just the number, just the constant, that is going to be negative 12. And so all I have to do at this point now is just put the numbers into the quadratic formula. So step 3 is substitute values into quadratic formula and simplify. So here, if I have this, the quadratic formula, I'm going to put 2 in for B, 2 in for B, Find 2 squared minus 4 times a. A is also 2. Whoops, I'm going to put the multiplication in between there, or else it looks like 42. And then I'm also going to put times c, and c is negative 12. All over 2 times a, and again, a is 2. Okay? So at this point, if I were to solve this, let's keep simplifying this. As I'm going to say, okay, well, now I know, and actually I should just copy and paste the previous one. Now I know this is true. Oops. So plus or minus 2 squared, well, I don't have to write 2 squared anymore. 2 squared is 2 times 2. That is 4. And then minus 4 times 2 times negative 12. Well, 4 times 2 is 8. 8 times negative 12 is negative 96. So this would be negative 96. All over 2 times 2. 2 times 2 is 4. Okay? Again, I'm going to simplify this. 4 minus negative 6 now. So again, before this, I just did 4 times 2 times negative 12. I didn't include that minus there, so that still has to stay. And we found out that to be negative 96. And so 4 minus negative 96, well, that's nice and easy for us because minus and negative is like plus a positive. So 4 plus 96, that's 100. And at this point, I know what the square root of 100 is. It might not be easy for every single question that we have, but this one it was. I already know what the square root of 100 is. The square root of 100 is 10. And so we have two solutions here. Our first solution, so x, our first solution, and I don't know why it keeps underlining my equations, but my first solution is x is equal to whoops, that's not what I wanted either. Negative 2 plus 10 over 4. And my second solution, and the second solution now is very similar to the one that we just had, but now x is equal to negative 2 instead of plus 10, it's minus 10 divided by 4. And if I simplify this, x is equal to, well, negative 2 plus 10, that's 8. 8 divided by 4, that's 2. And then our second x value is negative 2 minus 10, that's negative 12. Negative 12 divided by 4 is negative 3. And these are our two x-intercepts here, 2 and negative 3. So if I were to put this into my graph, and again, I'm going to do that, if I put 2m squared plus 2m minus 12 here, so instead of 2m, I'm just going to put 2x. 2x squared plus 2x, minus 12, our two x-intercepts is negative 3 and 2. Negative 3 and 2. And again, when we did a quadratic formula, we still got negative 3 and 2. Okay. And last but certainly not least, graphing quadratics. So that dealt with solving quadratics. Now we're going to go with graphing quadratics. And the last thing we need to do is I'm going to give you the steps and how we're going to graph quadratics. Steps. First, step 1. Find axis of symmetry. And hint, this is going to be a question on your quiz. The axis of symmetry is x is equal to negative b over 2a. Negative b over 2a. And again, this comes from your initial equation. What's your b value? What's your a value? And substitute it in. So that's going to be your axis of symmetry. So actually, you know what? I'm going to give us an example here. So how do we graph the equation so I can actually do each step each time? How am I going to graph the equation? Y is equal to negative x squared plus 2x plus 1. And again, we've already talked about this, but because it's a negative in front of the x squared, this is going to be concave down. A negative on the x squared tells me it's going to be concave down. It's going to be a negative value, and we're going to have its maximum value. So concave down means we're going to have the maximum value. Concave up is going to be the minimum value. Okay? But x is equal to negative b over 2a. That is going to be your first step. So in this case, my b value is 2. So x is going to be equal to, my b value is 2. Negative 2 all over 2 times a. A is negative 1. 2 times negative 1. Whoops. 2 times negative 1. And so this is equal to, here, negative 2 over negative 2, because 2 times negative 1 is negative 2, and that is equal to 1. And so what this tells me, and I would draw the axis of symmetry every single time you get to this point, is your axis of symmetry is going to be at x is equal to 1, or it's going to be this vertical line when x is 1. So you go to your x-axis, you go to your x-axis, go to that number, so x is equal to 1, and then just draw a vertical line up and down. Okay? At this point, step 2. Actually, I can't remember if I did this exact problem for your study guide, but if I remember having an x equal to 1, it's not always going to be like that. It just kind of is a coincidence. But step 2 is find your vertex by plugging in your axis of symmetry in for x in your original equation. So here, my original equation, and I'm going to kind of copy and paste it. Sorry, my neck is kind of hurting me a little bit today, but I'm going to copy and paste it and say, okay, my axis of symmetry is positive 1. So now what I'm going to do is, instead of writing x, I'm going to write positive 1. So y is equal to negative x squared, but now it's going to be 1 squared. Negative 1 squared plus 2 times 1 plus 1. Okay? And so if I continue this, I say, okay, 1 squared is 1, so negative 1 is going to be out in front, plus 2 times 1, that's 2, plus 1, that's going to give me a value. My y value when x is 1 is negative 1 plus 2, that's 1, 1 plus 1 is 2. And so what I figured out is my vertex, so actually let me do this here, my vertex is at 1, 2. The 1 came from the axis of symmetry. Your 2 comes from when you plug that axis of symmetry in and solve for y. And so this is going to be my axis of symmetry here. I mean, this is going to be my vertex. My vertex is going to be at 1, 2. Okay? At this point, step 3, I would advise doing one of 2 things. In this example, I think it would be really easy to either graph your y-intercept or make a table. And really what that is just make a table and plug in different values and see what you get out to see what the graph looks like. But I'm actually going to do the easier one of the 2, and how you can, and I'll tell you actually in a little bit. I'm not going to go to it right now, but I'm going to tell you how you know if it's easy to do the y-intercept piece. Okay, so y-intercept here is, well, your y-intercept, again, your y-intercept is when x is equal to 0. Well, x is 0. If I put 0 in for x here, well, that makes this 0, the x squared. That makes this 2x also 0. So all you're left with is just the 1. So now I know my y-intercept here is 1. And so this rings true for every single one of your quadratic functions. Your y-intercept is always going to be just the number at the very end. That's always going to be true. It's just going to be that number at the very end. And so if I draw this y-intercept here, and I'm going to draw it in, actually, let's just draw it in a different color pen. Let's just do it in green here. So if I draw my y-intercept, oops, what's going on here? Draw my y-intercept. My y-intercept is 1. What we realize here, and this is the big property of the axis of symmetry, is the axis of symmetry is kind of like if I folded my parabola onto itself, it would be line up perfectly. So in other words, it's a mirror of itself. So if I go down 1 and over to the left 1, I have to go also down 1 and over to the right 1. And so this is a second point here. And at this point, I can now graph my parabola. Just kind of connect the points. You don't have to be exact. You're taking it. Whoops. That was bad. Okay, you don't have to be exact. We have to be better than that. So if I graph this point, graph this quadratic here. Try your best on when you do this on Cami. Doesn't have to be perfect, like I said. As long as you have 3 points and can justify, can justify each of these 3 points, that is totally fine with me. Okay, so graph this, continue the graph. There we go. So again, if the axis of symmetry splits the parabola in half, so if you go down 1 to the left 1, you also have to go down 1 to the right 1 to get your second point. If I were to go down 1 and over to the right 3, I would have to go down 1 and over to, sorry, if I went down 1 over to left 3, I would have to go down 1 over to the right 3. So you just have to do the exact same thing. And the reason, and like I said, I told you, you can tell if you want to go with your y-intercept, because if your y-intercept is between -10 and 10, that's a great thing to do, because you can easily see, you can easily plot that on this graph. You can easily plot the y-intercept here, and then just kind of adjust for your third point. But if your y-intercept is not on the between -10 and 10, that's when I would make a table and choose values really close to your x value at your vertex. So what you would do is you would, if you were given this and you didn't know what your y-intercept was, always choose, so since my x value is 1, I would choose x values of 2, 1, -1, -2. If, for instance, if my vertex was way over here on any given problem, that's an x value of -6. So I would plug in values like -5, -7, -4 into your table and see what values you get out. And last thing I want to know before I get done with this video, because I know this is a long one, we can tell that we did it right because, again, we said this was going to be concave down, and we have that concave down. And that maximum and minimum value is going to be at your vertex, and that maximum value here is at 1, 2. Again, if you have any questions, please feel free to send me an email during the quiz or before while you're studying. I can answer to my best of my ability, and I will get back to you as soon as I can. Please have a great day, and don't stress over this quiz. It is going to be graded, however, so just give it your best shot. A lot of it is going to be multiple choice. It's going to be true and false. Some of it is going to be word problems. When you're doing the word problems, make sure you understand what the question's asking of you. If the question's ever asking you, what is it when the height is 0, really what that means is, when is it when it hits this x-intercept? Whenever it says the height is 0, so in other words, if I jump into the air, it's going to go up, I'm going to go up, and I'm going to get back down to the ground, or when it's going to be on the x-intercept. So that's a huge thing. If you're finding out when when it hits back in the ground, if you ever get a question about projectile, that's when your y value is 0, and that's when I would use either the quadratic formula or the factoring piece. If you're asking at what time your parabola is at its peak, that's when you would do this, find this axis of symmetry, and then if it asks you, well, what is the height, that's when you would plug that into your equation. I know this is a lot of things to remember, a lot of things to do, but really just make sure you understand what the question's asking of you, and I can answer as many of your questions as you want, barring them not giving you the answer. So please feel free to ask any questions. I will not give you all the answers, but I want to help you, as I know this is kind of a tough time learning online, and this is a tough subject as well. So I want to help you as much as I can. So again, please feel free to email me, use the discussion boards when you're studying, and I'll get back to you as soon as I can. I hope this helped. Hope this doesn't confuse you some more, but I hope you guys have a great day, and I'll see you guys and hopefully grade these quizzes, but I hope to see you in another video on Monday. Thanks and have a good day.